Hi everyone, this is the video for how to partition a line segment. So in 9.1 we talked about how to find the midpoint of a line segment. So this is kind of the same idea, except we're not exactly splitting our line in the middle. It's going to be some other ratio. So we have our steps here. So it says we're finding the difference between the x and y coordinates. We're always starting with that second point first. And then we're going to multiply those difference by our ratio. And they always tell us our ratio. So for example, if they tell us that the ratio is 2 to 1, then the number that we multiply by is 2 to 3, 2 over 3. So this is the formula here that we would use, the a over a plus b, because it's how many pieces of our line we're splitting our segment into. So that's important. And then we add those values to our original point, and that'll be our new point. I wrote it out as a formula. That looks really confusing to me, but if you like formulas, then there you go. You can just plug everything in and have at it. But here's the steps that are telling you to do the same exact thing. So let's take a look at our first example. So it says that we want to find the point P that's lies along that line segment with those endpoints that partition or splits the segment 2 to 1. So that means our point P is going to be somewhere over here, because this part from C to P is going to be twice as big as from P to D. And we know that because of this. It'll be 2 parts to 1 part. Okay, so as our step said, first we need to find our ratio. So our ratio is found by doing a over a plus b. So a over 2 plus 1 would be 2/3. So the whole line would be worth 3, and the first part is worth 2. So 2, 1 makes the whole line worth 3. So step 1 says to find the differences in x. So the x difference would be the second x value minus the first x value. The difference for y would be the second y value minus the first. Now for step 2, it says to multiply these differences by our ratio. So we're going to multiply them by 2/3. So remember, you multiply straight across. So 9 times 2 is 18. 18 divided by 3 would be 6. So that would be 9 times 2 divided by 3. So for the second one, it'd be 3 times 2 divided by 3. So this tells us how much we're increasing for our x coordinates and then our y coordinates. So that means I'm going to have to go over to 6 and up 2. So I'm going to add this to the x and add this to our y from our original point, C. So my original point, C, was -3, -2. So I'm going to add 6 and add 2 for my x and y. These are x and y. And then I'm going to get my new point P. So this would be 3, 0. So that means at 3, 0, I have point P that splits the distance of this line in a ratio of 2 to 1. So point P splits it into a ratio. This piece is twice as big as that piece. And that's it. So what we have to do is find the difference, multiply by a ratio, add that number to our original point. So let's go ahead and try another example. Okay, so for this example, it says that we want to partition it so it splits 2 to 3. So our first step, we need to find our ratio. So our ratio is a over a plus b. So that'd be 2 to 5. We find our x coordinate difference, which would be 5 minus -3, so 8. We find our y coordinate difference, 0 minus -4, which is 4. And then we multiply these by our ratio. So times by 2/5. So if we put that over 1 and multiply straight across, we get 16 over 5, which doesn't divide evenly like the first one did. So what we're going to do is to change it to a decimal. So we get 3.2. Now we'll do the same thing for y. So this would be 8 over 5, which is 1.6. So these are the numbers that tell us our difference, so how much we're moving. So we take our first point r, which was -3, -4, and we add this change to it. So we'd add 3.2 to our x and 1.6 to our y. So that would tell us that our point P would be 0.2, -2.4. Yeah, -2.4. And that's it. That's the point that splits it. Okay, so let's try one more together, and then you guys can do one by yourself. So let's look at the one below that. So find our ratio. So a over a plus b, 1/4. So now we'll do our x coordinates. So x2 minus x1, -5 minus 5 equals -10. And then we'll times it by our ratio and divide to make it a decimal. Now do the same thing for the y's. So y2 minus y1, 3 minus -2. So that's 5 times 1/4. Multiply straight across, be 5/4, which equals 1.25. So once you find your change, we add these to our original point. So our original point M is at 5, -2. So our x coordinate changes by 2.5. It gets subtracted since it was negative, and our y coordinate was positive, so we'll add it to the y coordinate. So that point P that partitions our line is going to be at 2.5, -0.75. And that's your final answer. So go ahead and pause and try the third example that's on the top, and then we'll do the fourth one together because that one's a little different. So try the third example, please. Okay, so we got our ratio is 4/5. We subtracted our x's, multiplied by 4/5, so we got our x change is 3.2. Same process for y. Our y change is -6.4. We add that to our original point J, and then we get that our new partition point is -1.4. So make sure you write down any questions you had for that one. So let's look at our last example at the bottom. This one is different. It said that it's divided by point D, so that's our partition point, and the ratio of 1:4. G is here, and our partition point is at 212, but we need to find out that other endpoint. So let's draw a line just so we have some kind of picture to kind of know what they're talking about. So it says we have line segment GH, and I'm just drawing like a normal horizontal line, but obviously this is on the coordinate plane, so it's not going to be like horizontal, it's going to be where the ordered pairs are. So we know that G is at -3, 2. And then they told us that point D splits it in a ratio of 1:4. So from G to D would be worth 1, and then D to H is worth 4. And point D is at 212. And we need to figure out where point H is. So the process is going to kind of be the same for this one. We need to figure out what's changing here. And we see that this is changing and it's worth 1, but the change here is worth 4. So this change is 4 times more than this change. So if we find the change between our x's, we get that there's 5 steps between here. So if an area of 1 is worth 5, what would an area of 4 be worth? 20. So that means to get to point H, we would have to add 20. So now for our y's, do the same thing. 12 minus 2 is 10. So that means when we change by 1, or the distance is 1, then we're changing by 10. We're adding 10. So for distance is 4, we would add 40. So I know on the other ones we always add from our original point to get that, but here we're changing from our our partition point to get here. So these changes are from this one. So we would add them to point D. So D is at 212. Our x coordinates to get to H would add 20. Our y coordinates would add 40. So that means that our point H would be at 22, 52. So we could go back and check our work and use these 2 points with our ratio of 1 to 5 and see if we get this, and that would be like the backwards way to check, but we will get it because it's the right answer. So I know this one might be a little confusing. We'll practice more in class. So make sure you write down any questions that you have so we can go over them. Warner out.